Good day, my wonderful viewers out there. You are welcome to Crispecul Education. Today on mathematics, we shall be looking at the topic derivatives. But there is more to these derivatives, but we shall look at how we can apply the principles of derivative in solving some basic and exceptional problems. Such problems you can see it in physics, or you can see it in questions like jamb questions, post-utme questions, even neco questions. Now, in a situation whereby we have this kind of question appearing to us, and maybe we kind of want to ponder or want to know what to do concerning this kind of question. Now, what do? We use simple hint of derivatives in solving them. But before that, there is need for us to understand the content of the question that we are about to solve. Now, let us look at what this question says. Say that a stone fall from a distance d meters in t seconds if d is equals to 60 square. Now, the question is, how far has the stone traveled in 2 seconds? And we should determine its speed when t is equals to 4 seconds. Now, in this scenario, now what do? At first, let us consider the question I here that says that we should find the distance, because I'm not talking about distance in 2 seconds. Now we'll say solution. For the I. We are told that our d is equals to 60 square. Now, and the d is in meter. Now, the question we want to say, we should find d, which is the distance, that is how far, when t is equals to 2. Now, we'll say if t is equals to 2, we substitute t equals to 2 in this equation of d equals to 60 square. So we'll say therefore our d now is equals to 6 bracket 2 bracket square in meter. So our d now will now be equals to 6 times the square of 2 is 4 in meter. Now therefore d now will now be equals to 6 times 4 will give us 24 meter. So the distance is 24 meter. Now, in solving the the problem of the now the says we should determine its speed when t is equals to 4 seconds. Now, remember that speed can be seen as an aspect of a graphical method. Now, under graphical method, when you plot the graph of distance against time, we have it as speed is equals to change in distance over change in time. Change in distance over change in time. Therefore, we have it that it is equals to the x over dt. The x over dt defines the speed of a body in this case now. So let us say that the speed of the stone falling down is the x dt. So we'll say if our d is equals to 6t square. Remember this hint. Now when we have x raised to the power of n equals to y, then our dy dx will be equals to nx n minus 1. That is the concept of the differential or the derivatives. So if we have something like this, so we have it that our ie dx dt will be equals to, we now have this as 6 times 2, then t raised to the power of 2 minus 1, which will now be equals to 6 times 2 will give us 12. T 2 minus 1 is t. So this one is in meter per second. So we have it in this manner. So our dx dt will now be equals to 12t, will now be 12t in meter per second. Now they set for 4 seconds. Now if t is equals to 4, we are asked to find the speed. Speed is equals to dx over dt. Sorry, speed is equals to change in d over change in t. That is, we have it as dt ds dt. So in this case, our t now for 4 seconds, the speed will now be equals to, say therefore speed will be equals to 12 times 4. 12 times 4, 4 times 2 is 8, 4 times 1 is 4. So we have it as 48 meter per second. So that is our speed. So our speed for the distance traveled, or our speed in 4 seconds, is 4 meter, is 48 meter per seconds. Thank you very much for viewing to this channel. Now here are the activities that you can also try on your own. Thank you.